Hello everyone. I want to welcome you back again in my this YouTube channel. Today we are going to discuss about the heat capacity of a given material, how to determine the heat capacity of a given material in our physics practical lab. Okay. So now what we will do is we have this type of experimental setup in our lab. Okay. So in this experimental setup, okay, this is a device, and whenever you on this switch, okay, this switch is off. Okay, whenever you on this switch, there will be the display. In this display you can see the temperature. In this display you can see the current which is supply, okay, uh, okay, to this mm, calorimeter. Okay, you can supply the current to this calorimeter, and these two are the I want to zoom this little bit. It is a calorimeter. Okay, this red wire should be connected with red, black wires should be connected with black, and here is one sensor. Okay, these two sensor converts to a one small stick. Okay, that stick will be inserted from this hole, and down in this cover there is the place to keep that metal substance. Okay, and in that metal substance there is a still one hole. Okay, you will insert that sensor which is made up of metal on that hole, and that hole and the sensor will be fused. And now what even is, from here, we supply the current, okay? Constant amount of current. We'll fix the current with the help of this P, okay? In our experiment, we have placed the current value 290, 290 milliampere, okay? Milliampere, MA, okay? 290 milliampere. We have fixed the current value. And after that, we have a given current there, and we have wait for the temperature to rise for 5 degrees Celsius. Okay, all this thing will be displayed in this symbol, but I haven't took the photo. That's my mistake. Okay, I'm very much sorry for this. Okay, I will explain in my view. Okay, I have told you the connection. Okay, connect these two, red with red, white, black with black. This red and black will be fused with one metal wire like the needle. Okay, that needle you will insert from here, and insert you will have the three metal pieces: silver, aluminum, and copper. Okay, we'll talk about that later. Okay, in that silver, we'll take the silver at first, whose mass is known. Okay, you will insert that, and you will close the lid. Okay, don't while closing the lid, be careful that the thread and the hole is inserted. Okay, so that if the from the calorimeter the two wire is coming, that's bringing current. Okay, that heat the metal. Okay, that heat the metal, that is silver. Okay, when the metal is heated, and then what happens, the sensor gets the temperature, and it will be displayed on the board. Okay, and don't leave this back end so that air can go inside and the temperature will not be noticeable. Close that if possible airtight. Otherwise, a little bit close this fully. Okay, how you can. Okay, this much. Now after that, we'll take the observation for silver. Okay, we know silver. And initial temperature was 30.9 degrees Celsius. Okay, before heating. Okay, before at first, whenever you have turned this on, the temperature is displayed here 30.9. Okay, temperature is displayed 30.9, and we have waited till 35.9 degrees Celsius rising temperature. The final temperature is 35.9. While rising this temperature, we have waited for a limited time. The time is 8 minutes and 20 seconds. You will set up a timer, okay? For 8 minutes and 20 seconds, you have wait. That is for 500 seconds, we have wait for rising 5 degrees Celsius. 30.9 to 35.9, it is 5 degree Celsius rising, okay? T2 minus T1 is 5. So we have supplied the current 290 milliampere, 0.29 ampere, and the mass of silver is 7.8 gram, and the specific heat capacity of silver is 232 joule per kg or Kelvin. But here, our experiment was to determine specific heat capacity, but we are taking specific heat capacity of silver. Why? Okay, the question may be why. So this is for aluminum and for copper. We will talk about this later. So what we have done, we have used this formula, okay? I means the current 0.29 ampere. R means the resistance of that box, that calorimeter, okay? 5.2 ohm, okay? That T means time, 500. W means water equivalent. SW means specific heat capacity of water. MS means mass of silver. SS means specific heat capacity of a silver. Okay, mass of silver is 7.8 gram. Converting to kg will be this. And this is specific capacity. T2 minus T1 is 5 degrees Celsius. From here, what we have got is, we have solved this and divided by 5, okay? It will be equal to 43.732 WSW plus 1.809. And what you will do, WSW, we have got water equivalent, and specific capacity of water is 41.9 value, okay? Joule, that is Joule. Okay, whenever you divide by the SW, specific capacity of water, you will get the water equivalent, 9.98 gram. So now I want to describe what is water equivalent, okay? I want to describe what is water equivalent. Suppose you have a substance, okay? Suppose you have substance, you have any substance, okay? You have supplied the amount of heat, dq amount of heat you have supplied. The substance have a mass m, and its temperature is raised by dT, okay? Fixed temperature. dq is fixed, dt is fixed. For this max, yes, we are sure. Let the dq be something joule, dt be something degree, 1 degree, 2 degree, okay, whatever. So this is the mass of substance. Okay, we are giving some heat, and the temperature is being raised by a certain degree Celsius. Now we are taking water. Okay, the mass is unknown. For what mass of water, okay, for what mass of water, if you supply a same amount of heat and the same degree rise in temperature is there, that is called a water equivalent. Okay, I repeat once. Okay, for any substance, this is any substance, this is water. Okay, TER. This is water. For any substance, if you supply a certain amount of heat and the certain amount of rise in temperature will be there, that is obvious. Okay, for water, if you supply same amount of heat and for the same degree rise in temperature, what amount of water is required, that is for the water equivalent. Okay, I hope I made you clear about this. Now, water equivalent is out. Now we'll take the same formula for aluminium. Okay, before I mentioned mass of aluminium, specific heat capacity we need to determine now. Now we are doing actually, with the help of specific heat capacity of silver, we are determining the specific capacity of, with the help of specific capacity of silver, we have determined water equivalent. With the water equivalent, we are going to determine the specific capacity of aluminium and copper. Okay, this is our work for today. Okay, now what we will do is for aluminium. Now for aluminium, what we will do is I square RT, same formula is there, T2 minus T1, okay, that is 5. Now we'll remove the silver from there. We'll keep aluminium and we'll see the initial temperature, final temperature, and then notice the time period. Okay, for aluminium, again, same thing will be repeated to that calorimeter. Okay, let us put the current, same 0.29. Okay, 29. 290 milliampere means 0.29 ampere. Okay, same thing is there. Now water equivalent, WSW value we have taken from up. Okay, now SA is unknown. Now we will determine SA, that is specific capacity of aluminium. Similarly for copper, you will do the same thing again and you will get the mass of copper, which will be defined. This we need to determine. Now for 5 degree rise in temperature, what time is required? 514 second. Here 505 second was required to rise a 5 degree temperature in aluminium. For rising 5 degree temperature in copper, we need 514 second. That means 514 second means something minutes, something second. Okay, that is the specific capacity of copper. With this, we have completed this experiment. It's very easy to perform. Okay, but you need to wait a while. You need to wait for something second, 500 second. That means 1500 second. For the setup, we keep more 500, more 8 minutes will be lost. Okay, more 500. That means around 2000 second we need to wait. Okay. 1000 second means nearby how much? Let me calculate 2000 divided by 60. 30, around 33 minutes we need to wait. Okay, it falls at 32. Around 33 minutes we need to wait for performing this experiment. Okay, we need calm. We need to be hopeful. Okay, then surely we are going to get this data. Okay, if there is something error in specific capacity of aluminum for copper, you can take out percentage error, any error which you wish. Okay, which will be effective for this. Okay, with this, I want to conclude my today's video. I want to be out from this video. Hope we'll meet again. Okay, if you like this video, don't forget to share and subscribe and comment on my comment section. Okay, thank you very much. It will help me to improve if with a comment. Okay, thank you very much and bye bye.